Hello guys, welcome back to my channel. This is the lecture 6 of quadratic equations. So in this video we will again solve a lot of questions about quadratic equation, and these questions are mainly collected from JEE Mains and JEE Advanced previous year question papers, and this most probably will be your last lecture on the quadratic equation. So let's start the video by let's start the discussion by showing you the first question, which is actually came in JEE Mains 2003, right? So can you please trying to answer what will be the how the process what will be the process for which we can solve this question? The question given to you is the value of a for which one root of the quadratic equation, which is a square minus 5a plus 3 times x square plus 3a minus 1 into x plus 2 equals to 0, is twice as large as the other is, right? So first of all, here the quadratic equation is given to you is, let me minimize this particular question into smallest form so that I will have more spaces, right? So yeah, so what the quadratic equation is given to you, which is a square, right, minus 5 times a plus 3 into x square, right, plus 3a minus 1 times x plus 2 equals to 0, right? This is the quadratic equation is given to you. So basically we have to find out the value of a for which one root of the quadratic equation is twice as large as the other, right? So if we take one root is alpha, then the second root will be 2 alpha, because it is given na one root, if one root is twice as the other, right? So let one root, let roots of the quadratic equations, roots of the quadratic equation are alpha comma 2 alpha, right? So you can take the roots in the form alpha comma 2 alpha, and here you can see the coefficient of x square is a square minus 5a plus 3, and the coefficient of x is 3a minus 1, and the constant term is 2, right? I mean the coefficient of x to the power 0, right? So now applying the relation between roots and coefficients, right? Applying the relation between roots and coefficients, right? I mean the sum and the product of the roots, right? So if we apply the relation between roots and coefficients, then alpha plus 2 alpha, I mean the sum of the roots, will become minus b by a. Here instead of b we have 3a minus 1, and instead of a we have a square minus 5a plus 3, right? So we can write down here as minus times 3a minus 1 upon a square minus 5a plus 3, right? So it will be 1 minus 3a upon a square minus 5a plus 3, right? So if we just calculate this part, alpha plus 2 alpha will become 3 alpha, and 3 alpha will be 1 minus 3 alpha upon 1 minus 3a, 1 minus 3 upon a square minus 5a plus 3, right? So what will be the value of alpha? It will be 1 minus 3a upon 3 times a square minus 5a plus 3, right? This is a condition which I got by solving the sum of the roots, right? So what will be the product of the roots? It will be alpha times 2 alpha, which is equals to c upon a, right? So here c means 2 and a means a square minus 5a plus 3, right? So a square minus 5a plus 3. So you can calculate this. It will be 2 times alpha square, which is equals to 2 upon a square minus 5a plus 3, right? Here 2 will be cancelled out, and we will get alpha square equals to 1 upon a square minus 5a plus 3, right? So here we have got alpha, and here we have got alpha square. So we can put the alpha into alpha square, right? We have to find out the value of a. So putting 1 in, let me write down this equation as 2. So 1 in 2, comma, we get what we get. Let me first let me first erase that part so that I will have more spaces. I think you can write down this, right? So let me wait a second, few seconds, so that you can write all these things. Yeah, so let me erase that part, right? So if I will erase that part, so maybe we'll have more spaces, right? So maybe we'll have more spaces. Wait a second, please. Right, so let me write down. So if we put alpha in alpha square, so we will have 1 minus 3a upon 3 times a square minus 5a plus 3, that part whole square, equals to what we have, 1 by a square minus 5a plus 3, right? So if we just applying this part, just wait a second, let me erase that part so that we can try to solve this question, right? We will have more spaces. Yeah, so if we solve this particular question, then it will be 1 minus 3a whole square upon 3 square will be 9 times a square minus 5a plus 3, that part whole square, equals to 1 upon a square minus 5a plus 3, right? So if we cancelled one part with that part, it will be only a square minus 5a plus 3 will be there, right? So it will be 1 minus 3a whole square upon 9 times a square minus 5a plus 3, which is equals to 1, right? So 1 minus 3a whole square will be equals to 9 times a square minus 5a plus 3, right? So let me break that part into a minus b whole square. So it will be 1 minus 2 times 1 times 3a, so it will be 6a plus 3a whole square, it will be 9a square, right? Equals to 9a square minus 45a plus 27, right? So 9a square and 9a square will be cancelled out. So we will have 1 minus 6a plus 45a minus 27, which is equals to 0, right? So you can calculate, so it will be 39a minus 26, which is equals to 0, right? So what will be the value of 39a? It will be 26, right? So what will be the value of a? It will be 26 upon 39. So we can cancel this by 13, so it will be 2 and it will be 3. So here you can see the value of a will be 2 upon 3, right? So you can understand what am I trying to say. Since the roots of the quadratic equation is twice as large as the other, so we took the roots as alpha comma 2 alpha, and after that we are just applying the relation between roots and coefficients. And by this particular formula, after deriving some calculations, we will got the value of a, right? So the value will be 2 by 3. So option number B is the correct option. So you can understand what the questions, what the solution would look like, right? So let's move to the next question. This is also a very important question. This is basically a question which has a lot of theories of discriminant basically. So the question says, for all x, sometimes for all x can be written as for all x, like this symbol. This symbol is means for all, right? You have to remember that thing. So for all x, x square plus 2a times x plus 10 minus 3a is greater than 0, then the interval in which a lies is. So we have to find out the interval for which this particular quadratic expression would be greater than 0, right? So here are some options given to you. So let me first write down the quadratic equation, which is x square, right, plus 2ax plus 10 minus 3a, right, which is greater than 0. First of all, right, if d is less than 0 and a is greater than 0, then the quadratic expression, which is suppose ax square plus bx plus c, must be greater than 0, right? So let me check what is the sign of a. Here a means a is nothing but the coefficient of x square. So here coefficient of x square is 1. So 1 is always greater than 0. So a is greater than 0. Since a is greater than 0 and this particular expression is positive, that means the discriminant should be negative, right? For which that particular quadratic expression will be greater than 0. So can you please trying to solve what will be the discriminant? Can you please trying to solve by your own? Let me wait for a minute, for a few seconds, so that you may solve by your own, right? Okay, let's solve this question. You know, right, for a quadratic equation ax square plus bx plus c which is for a quadratic equation ax square plus bx plus c which is equals to 0, the discriminant will be b square minus 4ac, right? So similarly, for that quadratic equation, which is x square plus 2ax plus 10 minus 3a, the discriminant will be 2a whole square, right, minus 4 times 1 times 10 minus 3a, right, which is less than 0. So if we calculate that part, it will become 4a square, right, minus 4 times 10 minus 3a, which is less than 0. So it will be 4a square minus 40, and it will be 12a, which is less than 0. So I can take common 4, so it will be a square minus 10 plus 3a, right, so which is less than 0. So if I just divide both sides by 4, since 4 is a positive number, then the inequality sign will not change, so it will become a square minus 10 plus 3a, which is less than 0, right? So a square plus 3a minus 10 will be less than 0. So I can factor this particular term, particular expression, right? So that the factorization will be a plus 5 times a minus 2, which is less than 0, because after calculating this you will get a square plus 3a minus 10, right? So now we have to apply the inequality form, right? So I think you guys are already familiar how to solve these inequalities, right? So let me first delete that part. Yeah. So the inequality is given to you, which is a plus 5 times a minus 2, which is less than 0. So if we put that part equals to 0, we will get a equals to minus 5. And if you put that part equals to 0, we will get a equals to 2, right? So let me plug in these values on the real axis. So minus 5 will be somewhere around there, and 2 will be somewhere around there. And if we apply the wavy curve method, then that part will be positive, that part will be negative, and that part will be positive. I mean, this total part will be positive for that region, this total part will be negative for that region, and this total part will be again positive for that region, right? So we have to take only the negative part, right? Because here that particular expression is less than 0. So negative part will be in that particular range, and since it is strictly less than 0, so we don't need to take, we should not take, or we must not take minus 5 and 2, right? So it will be minus 5 less than a less than 2, right? I mean, a belongs to the open interval minus 5 to 2. So what will be the option? What will be the correct option? Which is B option is the correct option. So you can understand, right? So B option would be the correct option of this particular question, right? So let's move to the next question. I'm just basically applying the discriminant formula and also sign of a quadratic expression. I'm just applying this particular formula. Okay, so let's move to the next question. This is also a very important question which actually asked in JEE Mains 2007, and the marks you can see is 3 marks actually, right? So the question says, let alpha comma beta be the roots of the quadratic equation which is x square minus px plus r equals to 0, right? So the given quadratic equation is x square minus px plus r which is equals to 0, and it says that alpha comma beta are the roots, right? Are the roots of the equation, right? Of the quadratic equation. I'm just write down eq to the power n, right? I mean equation, right? So alpha and beta are the roots of this quadratic equation, and alpha by 2 comma 2 beta be the roots of the quadratic equation or of the equation x square minus qx plus r equals to 0. So another quadratic equation is given to you is x square minus qx plus r equals to 0, and what are the roots? Which is alpha, which are alpha minus beta comma 2 beta, right? These are the roots, right, of that equation. So if I just write down this particular equation as number 1 equation and this equation as number 2 equation, so from one equation, if we apply the relation between roots and coefficients, and we have to find out the value of r. So here you can see then the value of r is, right, in terms of p and q. The options is in terms of p and q, right? So from first equation, if we apply the relation between roots and coefficients, then it will be alpha plus beta which is equals to minus of minus p upon 1, right? Minus of minus p upon 1. So it will be only p, and the product of the roots will be r by 1, right? R upon 1, so it will be only r. So here you can see alpha plus beta is p and alpha times beta is r, right? So from second equation, what we will have is basically you can see the first root is alpha by 2 and the second root is 2 beta. So if I just applying the relation between roots and coefficients for these two roots, then it will be alpha by 2 plus 2 beta which is equals to minus of minus q upon 1, right? Minus of minus q upon 1, so it will be only q, right? So you can see alpha by 2 plus 2 beta will be nothing but only q. So if I just take the LCM, so it will be 2 and it will be alpha plus 4 beta which is equals to q. So what will be the value of alpha plus 4 beta? It is nothing but 2q. So you can understand, right? So what will be the product of the roots? Let me write down here, which is alpha by 2 times 2 beta which is equals to r upon 1, right? R upon 1. So if I cancel this 2, it will be alpha times beta which is equals to r. So here you can see we got 4 relations actually. One is this, similarly another is this, another is this, and another is this, right? So from this and this relation you can see alpha times beta will be r, right? Alpha times beta will be r. But what we have to find, we have to find the value of r only, right, in terms of p and q. So it is necessary that we have to find out the value of alpha beta so that we can put here in alpha and beta in p and q in the alpha and beta form so that we can get the value of r, right? So let me write down that equation as suppose star, and this is 2 star, right? So from star what we have suppose alpha equals to p minus beta, right? From star we have alpha equals to p minus beta. So let's put the value of alpha in 2, right? 2 star. So if we put the value of alpha in 2 star, we will have p minus beta plus 4 beta, p minus beta plus 4 beta which is equals to 2q, right? So it will be p plus 3 beta which is equals to 2q, right? P plus 3 beta which is equals to 2q. So can you tell me what will be the value of 3 beta? It will nothing but 2q minus p. So can you tell me what will be the value of beta? It will be 2q minus p upon 3, right? 2q minus p upon 3, right? So we got the value of beta, right? So we got the value of beta. So let me erase that part so that I can get the value of alpha. Let me erase that part. That will be more than sufficient for me, to solve this question, right? So yeah, so we got the value of beta here, right? This is also very important. So let me put beta in star. So let's put beta in star. So we will have alpha plus 2q minus p upon 3, right? 2q minus p upon 3, which is equals to p, right? So what will be the value of alpha? It will be p minus 2q minus p upon 3. So if you just take the LCM, so it will be 3 and it will be 3p minus 2q and it will be p. So it is nothing but 4p minus 2q upon 3, right? So you can see the value of alpha. Let me sorry. So let me clear that particular part. Yeah, okay. So here you can see the value of alpha will be 4p minus 2q upon 3, right? So I can take the common 2 from the numerator. So it will have 2 times 2p minus q upon 3, right? And the value of beta is 2q minus p upon 3. So we have to find out the value of r, right? And we know r equals to alpha times beta, right? We know r equals to alpha times beta. So let me put the value of alpha and beta in terms of p and q. So it will be 2 times 2p minus q, 2 times 2p minus q by 3 into times 2q minus p upon 3. So here 3 times 3 will be 9 and 2 is there, right? 2 is there. So it will be 2 upon 9 times 2p minus q, right, into 2q minus p. So let me check which option is the correct option. Which option is the correct option? Here you can see first option is not correct because here p minus q is there and we haven't any kind of term related to p minus q, right? So that option is not also correct. That option, let me check. This option is not correct because here q minus 2p is there and 2q minus p is there. 2q minus p is there, 2 by 9 is there, but 2p minus q is there. But here we have q minus 2p, so that is not the correct option. But the option number D is the correct option. Here you can see 2 by 9 times 2p minus q times 2q minus p, right? So we got the answer. So this is the correct option of this quadratic equation, right? Of these quadratic equations. By applying this particular formula, we are just basically applying the discriminant formula or the relation between roots and coefficients, right? So you can understand how actually I am solving these questions, right? Yeah. So let's move to the next question. This is also a very important question and you will learn a lot of things from these questions also, right? So the question says, if the roots of the equation, if the roots of the equation bx square plus cx plus a equals to 0 be imaginary. Let me write down this thing as star. The roots of this quadratic equation be imaginary. Then for all real values of x, the expression which is 3b square x square plus 6bc times x plus 2c square is less than 4ab, less than minus 4ab, greater than minus 4ab and greater than 4ab, right? So these are the 4 options which given to you. So before starting to discuss about the deep knowledge about this particular question, let me first break what the question actually says, right? So let me first minimize these questions so that we have more spaces, right? So we have more spaces, right? Yeah. So yeah. So here you can see, if the roots of the quadratic equation, which is if the roots of this equation, which is bx square plus cx plus a equals to 0, right? This is the given quadratic equation, be imaginary. Since it is imaginary, then d is less than 0. I mean the discriminant is less than 0, right? And what is the value of d? Will be c square minus 4bc, right? It will be c square minus 4bc, which is less than 0. I mean b square minus 4 is c, b will be the coefficient of x. I mean the coefficient of x, whole square of coefficient of x minus 4 times the coefficient of x square into the coefficient of the x to the power 0, I mean the constant term. So we have c square minus 4bc less than 0, right? So let me write down this particular this particular inequation as star, right? Yeah. So let me see what other things says. Then for all real values of x, the expression this, right, is whether less than 4ab, greater than 4ab, whatever it may be, right? So here the expression is 3b square x square plus 6bcx plus 2c square, right? So this is also expression. So let me say this particular expression as y, right? Say, right? So what will be the equation? It will be 3b square x square. This is also an equation, but we have to write down in the simplest form. So it will be 2c square minus y equals to 0, right? Equals to 0, right? So 3b square x square plus 6bcx plus 2c square minus y equals to 0. So basically we have to find out the value of y only, right? So that we can say whether this particular part is greater than 0, less than 0, or what it may be, right? So here you can see for real values of x, the expression this is whether less than 0 or equals to 0 something, right? Since the values are real, right, then all values are real, so the discriminant will be greater than or equals to 0, right? Since the discriminant is greater than or equals to 0, let me check what will be the discriminant. It will be 6bc whole square minus 4 times 3b square times 2c square minus y, right, which is greater than or equals to 0, right, which is greater than or equals to 0. So if we just expand that part, so it will be 36b squared c square minus it will be 12 times b square times 2c square minus y, which is greater than or equals to 0. So it will be 36b square c square, right? I can take common 12b square right here. So if I take common 12b square from there, so we will have 3c square, right, minus 2c square minus y, which is greater than or equals to 0. Since 12 is a positive number, b square is also positive number, so both the part which is 12b square is a positive number, so you can divide by 12b square. So then the inequality which will not change, right? So if we divide by 12b square, it will be 3c square minus 2c square minus y, which is greater than or equals to 0. So let me break that part. So it will be 3c square minus 2c square plus y, which is greater than or equals to 0. So it will be c square, right, c square plus y, which is greater than or equals to 0. So can you tell me what will be the value of y? It will be greater than or equals to minus c square, right? So if I just let me check. So here you can write down c square as less than 4ab, right? So let me write down this as if I just multiply it by negative symbol, then it will be minus y, then the inequality will change, it will be less than or equals to, then it will be c square, right? And c square is strictly less than 4ab, right? So what will be the value of minus y? It is less than 4ab. So what will be the value of y, which is actually, if I just multiply it by negative symbol again, then it will be negative times negative y, and then the inequality will change, so it will be greater than negative times 4ab, right? So it will be y greater than negative times 4ab, right? So what we already let, which is y equals to 3b square x square plus 6 times bcx plus 2c square. So it will be 3b square x square plus 6bcx, right, plus 2c square, which is greater than minus 4ab. So what option is the correct option? Let me see. The correct option would be the option number B, right? Here the option says this particular expression is greater than minus 4ab. So this is the correct option. So you can understand what I did. basically I am just find out the relation of the discriminant from this equation since the roots are imaginary. So I got c square less than 4ab, and after that I have to take that particular expression with another variable. I just took the variable as y, and after that I calculate the discriminant which is greater than or equals to 0, so that I will get the relation which is y greater than minus 4ab, y greater than minus 4ab. Then I will get the value that I will get the relation which is that particular expression is greater than minus 4ab, right? So let's move to the next question. This is very important question, and this question is actually asked in JEE Mains, JEE Advanced 2019, right? So the question says 2013, right? So the question says if 3 to the power x equals to 4 to the power x minus 1, then x will be equals to a, b, c. These are the options with logarithmic functions, right? So actually this is a MSQ type question, and I have already told you that MSQ means multiple select question, right? Question. What does it mean, multiple select question, and what is the difference between MSQ and MCQ? I mean multiple select question and multiple choice question. Basically multiple choice questions have only one exact value, right? I mean those options, in those options we have only one correct option, right? And in multiple select question we have more than one option is the correct option. I mean there may be one option is the correct option, there may be two, there may be three, there may be four, right? There may be all options are the correct options. So this is actually a MSQ type question. Let me write down in that particular part that this is actually MSQ type question, right? So what equation we have given in the actually equation is given in the question, which is 3 to the power x equals to 4 to the power x minus 1. So basically we have to take the logarithm part. So take logarithm with base e on the both side, right? On the both side. So it will be log e 3 to the power x, I mean log 3 to the power x base e equals to log 4 to the power x minus 1 base e, right? So we know, right, the relation which is log base e a to the power n can be written as n log a base e, right? I mean the power will be on the coefficient of log a base e. So it will be x log base e and 3, which is equals to x minus 1 log 4 base e, right? So if I just take the x on the left side, which is x upon x minus 1, so it will be log 4 base e upon log 3 base e. So we know, right, we know another relation which is suppose log a base e upon log b base e is there. So we can write down this expression as log a base b, right? So we can write down this equation as log 4 base 3, right? So what will be the relation, which is x upon x minus 1, which is equals to log 4 base 3. So x equals to again x minus 1 times log 4 base 3, right? So let me break that part with multiple formation, which is x log 4 base 3 minus log 4 base 3, right? So x equals to that part. So if I take the part x in the left side, which is x minus x log 4 base 3, which is equals to minus log 4 base 3, right? So let me erase some part so that we will have more spaces. Yeah, so let me erase that part. Yeah, okay. So if I just take common x from the left side, we will have 1 minus log 4 base 3, which is equals to minus log 4 base 3. So what will be the value of x? It will be minus log 4 base 3 upon 1 minus log 4 base 3, right? So let me check, is there any option? So there is no option related to that part, right? So we can write down this particular, if I just multiple negative sign with numerator and denominator, so it will be log 4 base 3 upon log 4 base 3 negative 1, right? So yeah, so 4 base 3 negative 1. So let me again check, is there any option? No, there is no option. So basically we can just write that part as, suppose log 4 base 3 is there, so 4 can be written as 2 square and base is 3, so that 2 will be on the outside of the log, so it will be 2 log, the coefficient of log 2 base 3. So we can write down log 4 base 3 as 2 log 2 base 3, right? So that will be 2 log 2 base 3, and the denominator part will be same as 2 log 2 base 3 and minus 1 is there. So let me check, yeah, that option, A option is the correct option, you can see, right? A option is a correct option, 2 log 2 base 3 upon 2 log 2 base 3 minus 1. So let me check, is there other option is the correct option or not? So let me divide by log 2 base 3 on the numerator and denominator. So if I divide, then it will be 2 divided by 2 minus 1 by log 2 base 3, right? So log 2 base 3 is there. So let me erase some parts. Sorry. Yeah. So we have that relation, which is 2 upon 2 minus 1 upon log 2 base 3, right? So we know, right, another logarithmic function, which is 1 by log a base b, can be written as log b base a, right? So that part can be written as 2 upon 2 minus log 3 base 2, right? So I can write down this, right? So the option number B is also the correct option, is also a correct option, because it is same as this part. So let me check again, is there any other option is correct or not? So let me divide by 2 again. So if I divide by 2, so it will be 1 upon 1 minus half log 3 base 2, right? So we also know that if logarithm of a, suppose b to the power n is there, then b to the power n, a base b to the power n, so that can be written as 1 by n log a base b, right? So I can also write down 1 by n in terms of b to the power n, so 1 by 2 in terms of 2 to the power 2, so it will be 1 by 1 minus logarithm of 3 base 2 to the power 2, right? 2 to the power 2, so that will be 1 by 1 minus log 3 base 4. So here you can see option number C is also the correct option. Let me check that this will be the correct option or not. Basically this option is not the correct, because we got that particular option, not that one, and we cannot change that one to that one, that one to that one, that one to that one, that will not change, right? So option number A and option number B and the option number C are the correct options. So correct options are A, B, C, right? And D option is not the correct option. D option is not the correct option, right? Yeah, so you can understand this is also a very important questions. In these particular questions, we are just basically using the properties of logarithm, right? Properties of logarithm. So let me move to the next question. This is a very important question and you will learn a lot of things, right? So let me wait a second so that you can try to do these questions by your own. So please try this question by your own, and after a minute I will give you the solution of that question, right? please try to do by your own. Okay, I think you have got the idea of how you can solve this question, right? So actually the question says the smallest value of k, for which both the roots of the equation this, right, which is x square minus 8kx plus 16 times k square minus k plus 1, which is equals to 0, are real, distinct and have values at least 4. So what are the basic points? We have to find out the smallest value of k, right? And the second point is roots are real, right, and distinct, right, real and distinct. And the third option is and have values at least 4, and have values at least 4. So there is basically 3 main options are there, and also the given quadratic equation, right? So basically we have to find out the smallest value of k for which both the roots of the quadratic of the equation, which is x square minus 8kx plus 16 times k square minus k plus 1 equals to 0, are real, distinct and have values at least 4, right? So this is also a kind of a lengthy question, but let me try. The given quadratic equation is x square minus 8kx, right, plus 16 times k square minus k plus 1, which is equals to 0, right? So given that the roots are real and distinct, right? First of all, let me take these two important parts which are real and which is real and distinct, right? So if roots are real and distinct, then definitely d should be greater than 0, strictly greater than 0, because if d is less than 0, then roots are imaginary, so we don't need to take the case. If d is equals to 0, then roots are real but they are equal, so we should not take this particular particular thing. If d is greater than 0, then roots are real and they are distinct, so we have to take the third one, which is d greater than 0, right? So you can understand. So okay, so let me erase that part. Okay, so since d is greater than 0, so you have to find out the value of d, which is b square minus 4ac, that formula, where b is the coefficient of x and a is the coefficient of x square and c is the constant term. So d will be minus 8k, that part, whole square, minus 4 times 1 times 16 into k square minus k plus 1, which is strictly greater than 0, right? So let me calculate that part. Since it is minus 8k whole square, that will be 64k square, right? Minus 4 times 16, right? So can you tell me the value? It will be 64, right? It will be 64 times k square minus k plus 1, which is greater than 0. So let me break that part. So it will be 64k square minus 64k square, right, plus 64k and minus 64, which is greater than 0, right? So this part and this part will be cancelled out, and we will have 64k minus 64 which is greater than 0. So definitely 64k will be greater than 64. So 64 and 64 will be cancelled out. We can cancel by divide by 64. So we will have k greater than 1, right? So k greater than 1. So this is a relation which I have, which is k greater than 1, right? So here we have given that these roots have values at least 4. So roots, if alpha and beta are the two roots, then alpha should be greater than or equals to 4 and beta should be greater than or equals to 4. I mean at least 4. I mean the roots will be either 4 or more than 4, right? So let me say that let alpha comma beta are the roots of the given quadratic equation, right? So then alpha should be greater than or equals to 4 and beta should be greater than or equals to 4. So what will be the sum of the roots? I mean alpha plus beta, it will be greater than or equals to 4 plus 4, right? So alpha plus beta will be greater than or equals to 8. We got the relation, right? And another is that since the roots are at least 4, then f4 will be greater than or equals to 0. This is also a condition which we got from that particular given condition. So alpha plus beta is greater than or equals to 8 and f4 is greater than or equals to 0. So let me erase some part, which are these, right? Yeah, okay, let me write down. So alpha plus beta is greater than or equals to 8 and f of 4 is greater than or equals to 0. So since f of 4 is greater than or equals to 0, I mean f means that particular expression which is x square minus 8kx plus 16 times there, where f of x is nothing but x square minus 8kx plus 16 times k square minus k plus 1, right? This is the expression of this is the given expression, right? Say. So let me put 4 in the part. So it will be 4 square minus 8k times 4 plus 16 times k square minus k plus 1, which is greater than or equals to 0 by that condition, right? By that condition. Yeah. So 4 square will be 16 minus 8 times 4 will be 24. Sorry, it will be 32k plus it will be 16k square, right? Let me it's right, but let me write down this as with 16 only. So it will be k square minus k plus 1, which is greater than or equals to 0. Let me take the common 16 at there. So it will be 1 minus 16 times 2 will be 2k plus it will be k square minus k plus 1, right, which is greater than or equals to 0. So if I divide by 16, and since 16 is a positive number, then the inequality will not change and it will be 1 minus 2k plus k square minus k plus 1, which is greater than or equals to 0, right, which is greater than or equals to 0. So it will be 1 minus 2k, right, plus k square minus k plus 1, which is greater than or equals to 0, right? So it will be k square minus 2k minus k will be minus 3k and plus 1 will be 2, which is greater than or equals to 0. So what we have k square minus 3k, plus 2, which is greater than or equals to 0. So we can write down this particular inequality in the form which is k minus 2 times k minus 1, which is greater than or equals to 0, right? We can write down this by the factorization form, right? So if I solve this inequality, then if I just put that particular part is equals to 0, then we will have k equals to 2, and if I just put that particular part equals to 0, then we will have k equals to 1. So let me put 1 and 2 on the real axis. So we will have this part maybe 1, this part maybe 2, right? I'm just assuming that this is 1, this is 2, right? So by wavy curve method, what we have, the right part of 2 will be positive, the left part will be negative, and that part will be again positive. I mean, you can think like that particular part, that particular way, like that part is positive, negative, positive, positive, negative, positive, positive, negative, positive, negative, positive, negative, positive, negative, and that part will be followed. You have to start from the right side and you have to go to the left side. This is the actual method, but there are some other proven record has been exist on the internet also. You can check by your own, right? But this is actually a wavy curve method would look like for problem solving, right? So since that particular part is greater than or equals to 0, so we have to take the positive part, which is that part and that part, and since this is infinity and this is minus infinity, and since it is greater than or equals to 0, we have to take that 1 and 2 also in the closed interval. So k will be belongs to minus infinity to 1 close interval union close interval 2 to infinity, right? So k will be there, and again in the last solution I mean last part from the initial part we have k greater than 1, right? And now we have k belongs to minus infinity to 1 union close interval 2 to infinity, right? So if I combining these two with intersection, so what we have, actually we have k belongs to close interval 2 to infinity. Let me give you the introduction of how I can get that particular one, right? So you may have some questions on your mind that how I can get that particular thing, right? So let me first write down k belongs to 2 to infinity, right? So first of all, I have to plot that one on the real axis. Here real line is also drawn. So this is negative infinity and this is positive infinity, right? So let me write down that part is 1 and that part is 2, right? And let me take some vertical line which is this. So let me check my ink. So here given that k belongs to negative infinity to 1, right? So that part, right? That part, and we have 2 to infinity, that part, right? And there is also close interval in 1 and 2, so we have to take 1 and 2 also, right? Yeah, okay. So and also we have k greater than 1. I mean we have to take that part, right? K greater than 1. So I have to take that particular symbol because k is greater than 1. K is not equals to 1, right? So can you tell me what is the intersection of these two graphs? Basically that particular region, right? From 2 to infinity. So that is why k belongs to close interval 2 to infinity, right? So k is belongs to the close interval 2 to infinity. So let me see the question, which is what is the smallest value of k? So can you tell me what will be the smallest value of k? Since k started from 2 and onwards, so 2 will be the smallest value of that particular question, right? So what will be the minimum value? It is 2, right? So 2 will be the minimum value of that particular equation, right? That particular equation. So you can understand, right, what we did in this particular question. Basically we are finding the discriminant which is greater than or equals to 0 by a condition, and after that we got a relation of k which is k greater than 1, and after that we are solving that since the roots are greater than or equals to 4, then definitely f4 will be, I mean if I put 4 instead of that particular expression, which is x square minus 8kx plus 16 times k square minus k plus 1, right? So then f4 will be greater than or equals to 0. From that relation I also get another condition of k which is minus infinity to infinite to 1 closed union close 2 to infinity, right? and so I have to take the intersection because we have different values of k, right? So after taking the intersection, we got the value of k, which is k belongs to the closed interval 2 to infinity, right? So what will be the minimum value, I mean the smallest value of k according to the question, which is 2. So the smallest value of k will be 2. So I think you guys have actually understand a lot of things in this particular lecture, and I suggest you to go through most of the questions of JEE Mains and JEE Advanced previous year, so that if you solve these questions, I believe that you will understand a lot of things about how actually JEE Mains and JEE Advanced questions actually would look like. And also I believe that you may solve a lot of questions related to these particular topics if you solve all the questions of JEE Mains and JEE Advanced, right? And you will be able to secure a good rank in your JEE Mains and as well as JEE Advanced, so that you will be able to get a good branch in IITs, right? So that is all about for the lecture, and for that just do solve a lot of questions in quadratic equation, not only quadratic equation but in your whole syllabus. Like there are lots of chapters are there, so you have to solve lots of questions, and keep motivated and keep learning. Till then, take care yourself, and we will meet again, right? So that is all about for the lecture, and thank you for attending this lecture, and we'll meet soon. Thank you.